Welcome back to Stewart Science. This is about the 6th attempt I made at filming this video, and every time something goes wrong, I'm just going to post this no matter what happens. So today we're talking about how to name chemical formulas, and there's two different sets of rules depending on whether the substance is ionic or covalent. Go watch the types of bonds video if you want to talk about how to figure that out. But the gist of it is, if you have a metal and a non-metal, it's ionic. If you have two nonmetals, both from this side, it's covalent. So those rules are different for each one. So before you give it a name, you have to think about whether it's ionic or covalent. If it's ionic, the only thing you do is change the end of the second element to IDE. You actually do that no matter what, but that's all you do if it's ionic. So if I have NaCl, the name for that is sodium chloride instead of sodium chlorine. It's literally one letter different. You just change the N to a D. Sodium chloride. That's it for ionic. No matter what your formula is, no matter what your numbers are, no matter what, if it's ionic, all you do is change the second element, the non-metal part, to IDE at the end of that word. If you have MgO, it's magnesium oxide. If you have numbers, that doesn't matter either. If you have Al2 S3, that doesn't add anything else to our rules. It's still just aluminum sulfide. Aluminum sulfide. Ta-da! That's it. So ionic, super duper easy. Now on the covalent side, if I ask you for things that are covalently bonded, that involves what's called prefixes, which are words or parts of words that you attach to the beginning of a word. So, for example, here's the first 10 in a chemical, and you must use these on all of your elements if it's covalent. So, for example, water, normal water, which is H2O, if you're going to give it a chemical name, would be dihydrogen monoxide, because it's dihydrogen, that's 2H, that's 1, oxide, that's oxygen. So you have to use the prefixes if it's covalent. I can try a few more. Let's try, we'll go C2N5. Probably not a real thing. I'm just making up numbers here. So don't look this up on Wikipedia. It probably isn't a real chemical. But if it is, it would be, I should do 3 instead, since I just did 2. It would be tricarbon pentanitride. Tricarbon pentanitride. So notice it's still IDE at the end, but it just has these prefixes. Penta meaning 5, tri meaning 3. So if it's covalent, you have to add these few letters, and those letters are right here. Find a piece of paper and pencil and write them down, because you got to remember them. So if I give you any of these 1 through 10 on a quiz, you'll have to know them. So you only use those if it's covalent. If I gave you AL3, nope, ALF3, that would be aluminum fluoride. You don't use the tri because this is a metal, which makes it ionic. So if it's ionic, no prefixes. If it's covalent, prefixes. The only thing that you don't use the prefix for is if your first one is 1. If I had CH4, I wouldn't call it monocarbon tetrahydride. I'd call it carbon tetrahydride because the first one's 1. If it's 1, you just ignore it. You don't put a mono. But if the second one is a 1, you do put a mono. So there's a lot of rules with covalent. I'll summarize them here. Rule 1, use prefixes. Use these word startings for all of them. 2, only use mono if it isn't the first element. That's it. Those are all the rules. The confusing part comes into when do you use prefixes and when do you don't. You use the prefixes if it's covalent. You don't use them if it's ionic. You always use all the prefixes unless you're using mono and it's the first one. This is the exception. Right there. That's the exception. Okay, this is Mr. Stewart. Keep learning no matter what. Hey, just kidding, the video's not over. I decided I want to give you guys a few more examples of these rules in action because the mono at the beginning gets a little bit confusing. So you only use the mono when it's not the first element. So NO, no, some of you guys are going no and turning the video off right now. NO would be nitrogen monoxide, not mononitrogen monoxide. You only use the mono on the second or the third elements. So nitrogen monoxide. If it was NO2, it'd still be nitrogen, but now since it's a 2 instead of a 1 on the oxygen, it would be dioxide, nitrogen dioxide. Now that it's N2, it would be dinitrogen, and then O3 would be trioxide, dinitrogen trioxide. Tetra would be 4, so it would be N2, dinitrogen, tetroxide. And then N2O5 would be dinitrogen pentoxide. And the next one, you might have seen this on Mythbusters before, it's a gas that is much more dense than air. So if you breathe it in, it's dangerous because it doesn't naturally come out of your lungs. If you talk, it gives you a really deep voice because it's resonating your vocal cords differently. Point is, it's sulfur, not monosulfur. Hexafluoride is the 6. And then iodine, not monoiodine. Heptafluoride. There's a mistake in the website, so I'm not going to show you the next one because the name is actually wrong. So I'm going to move on past the octa. That one should be tetraphosphorus octoxide, but that's not what it says. Tetraphosphorus octoxide is what it should say. And then tetraphosphorus nonasulfide is what this should say. And then the last one would be ASA. It's not an element. That's also another typo. The S would be lowercase. Tetraarsenic decoxide would be the right way to pronounce that. This one here that I didn't cover up should be octoxide because it's O8. So now, as always, keep learning.